Okay, let's begin our today's class. So, what we're going to look into for today's class will be on the topic 4, which is called time value of money. So, time value of money is a technical term. Okay, so what it means is that the value of money, okay, is more right now as compared in the future. So, like for example, let's think about a scenario. Let's say your friend would like to borrow money from you. So you lend your friend $1,000. Okay, so do you expect your friend, okay, like do you hope that your friend can pay back this $1,000 as fast as he can, or you are okay for him to take his time, like to pay you back within a year or after 1 year, after 2 years, and so on? So which one? Do you prefer him to pay back as fast as he can, or do you prefer him to take his own time to pay back? What do you think? That's fast. First option, right? Yeah. Why? Because assuming if today you borrow money to your friends, okay, without charging any interest rate, so it will be more beneficial if, let's say, you take back the money as soon as you can, because the money will carry more of its real value right now on your hand as compared to in the future. Okay, so therefore, when you have the money on your hand, you can use it to actually increase your potential earnings as well, and most importantly, it carries more of the real value. Okay, so therefore, that's the idea of time value of money, in which we're saying that it's a concept that a sum of money is worth more right now, okay, than the same amount in the future. Okay, because of the earning potential, money due to the earning potential in the interim. Okay, so that's why we call it as time value of money. Now, in this topic itself, first of all, you will be introduced with some formulas, and then after that, you will learn financial calculators, like how to use financial calculators to derive the answers. And there are two concepts you need to know, which is called annuities and perpetuities. But for today's class, you may not need to use so much of these two concepts, but I will introduce to you first. So first of all, before we understand any of the formulas, let's understand what is simple interest and compounding interest rate. So first of all, when you say simple interest rate, right, it's just a very simple calculations. So like for example, you put 10,000 in an investments, okay, and let's say this investment says that it will generate 5% of returns, okay. So therefore, at the end, okay, you will be able to get so 10,000 of 5%. Okay, so therefore, this one is based on what we call as the simple interest rate. So 10,000 of 5%, okay, is 500. So that means that you will get these 500 returns, okay, from this investment. So therefore, at the end, okay, your initial investment is 10,000 plus this 500 return. Okay, so therefore, in the end, you will be earning 10,500. Okay, so therefore, here in this scenario, we are saying that this is based on the fixed principal amount, based on the original value that you pump in for this particular investments. Now, what we want to look into is compounding interest rate. Compounding interest rate means it's an interest on interest. Okay, so therefore, the interest that will be given to you will be based on the accumulated amount from the previous period. So, for example, okay, let's say in the year 1, the starting balance is 10,000. Okay, then let's say it's 5% interest, 5% returns is 500, right? So the ending balance will be 10,500. Now, in period number 2, when the interest rate will be to impose on you, right? It will not be based on the original amount, but it will be based on the ending balance over here, which is 10,500. So based on this 10,500, it's subject to 5% of the returns, which is 525. Okay, so therefore you have new ending balance, which is here. Okay, then carry forward. Okay, so the next period over here, when you were to get the 5% returns, is based on this starting balance again, this ending balance of the previous period. Okay, so therefore it's subject to to the same 5% interest rate, but the amount is higher. So your ending balance is higher as well. So at the end, you can see the value is getting larger and larger. This is what we call as compounding interest rate. So therefore, we can say that future value of this investment, of this money, is that present value bracket 1 plus r power of t. So therefore, present value is 10,000 1 plus interest rate of 5%, 0.05, power of t. T is the number of period. Like here is that there are 10 periods. Okay, so therefore at the end, how much is the answers? The answer that you will be able to get is 16,288 and 95. Okay, so therefore with compounding effect, you can see that there's a power over here. Okay, and therefore the graph will look like this exponentially. It grows exponentially like this. Okay, all good. Now, so we have understood the difference between simple interest rate and compounding interest rate. So now we are going to understand how all these formulas are being derived. Okay, so let's do some annotation. Okay, so we have just learned that future value equals to the present value bracket 1 plus r power of t. So therefore, this is a formula of future value. Okay, how much worth the cash is in the future. Okay, future value of the money. Now, if I were to calculate present value, okay, so how? So therefore, I can just move around. So we start with the original equation, F3 equals to PV, 1 plus R power of T. Okay, so if I were to get PV, so I will just move around. And at the end, I will be able to get this equation. Okay, so this is the equation for present value. Okay, that means that how much the worth cash right now. So that means we discount back, okay, to find out how much of the future cash flow are worth today. Okay. Now, next one, we are going to find out the equation for interest rate. Okay, so first we start with the original equation. F3 equals to PV bracket 1 plus R power of T. Now let's say I want to find R. So how? So I move PV to the left-hand side first. Then it becomes like this. And I want to move the power of T to the left as well. Okay, so it becomes like this. Plus R. Okay, so at the end, I move everything to the left. So this is the equation for R. R stands for my interest rate. Okay, so you can see it's the same as this one. Okay, now the next one, if I were to calculate the number of periods, which is t, so I'm going to calculate. So we start with original equation, F3 equals to PV, 1 plus R power of t. Okay, so therefore first I move the PV to the left-hand side first. Okay, now the problem is I want to find t, so how? So we have to use Lun. Okay, so I can rewrite it into okay, so now things will be easier already. So therefore, Lun F3 bracket PV is a proportion of Lun 1 plus R. Okay. So same thing as you can see, it's the same equation over here. So you have 4 formulas that you need to know over here. T means number of periods. Now, number of periods not always equals to years. Number of periods can be monthly, can be quarterly, can be half yearly, and not always yearly. Not always yearly. Okay, Ken, any questions so far? So these are how the formulas are being derived, but later we are going to use financial calculators to derive your answers. Okay, all good. Then let's move on to the next part. Okay, so two concepts I want you to know. So first of all, let's say you invest in an investments right now. So let's look into this timeline. You invest in year zero an investment. Now, assuming this investment will give you a fixed return every year forever until you sell off this investment. So in every year until infinity, you will get the same amount of equal payments or equal cash flow. Okay, so this PMP over here means by returns. So you see all these are equal returns. Okay, all these are equal returns, equal amount. And this is for forever. Okay, so therefore, if let's say I would like to calculate the present value of this investment, what should I do? Now, few conditions or few requirements that it must fulfill first before you are able to use this formula. The first one is cash flow must be the same. So like this one, PMP are all the cash flow. The cash flow are basically your returns. The every period's returns are the same. Okay, and for this one, it must be for forever, infinite. Okay, the maturity period must be infinite. That means it will last forever until you sell off this particular investment. Usually, this kind of investment is like preferred stock. So your shares are being prioritized. So every time the company makes money, they will pay you the dividends first. Okay, so if you were to calculate the present value of these investments for infinity one, okay, you straight away use the cash flow divided by interest rate. As simple as that. Okay, but remember, perpetuity means there is infinite series of equal payments. Okay, so we use this formula. Now the next one is annuity. Annuity is still the same thing. The cash flow must be the same. Same thing you invest in investments. Okay, every year you will get the same amount, but with a maturity period. Not forever, but until a period. Like for example, here until period 48. But still the same thing. You will have equal amounts. Then you have equal amount. So here we say that there is finite series of equal payments throughout the interim, throughout the periods. Okay, so there is a defined period of finite periods. Okay, so that means it will be mature. So for this one, the formulas will be like this. But of course, we are not going to use formulas for annuity. We are going to use financial calculator to derive our answers. So if you have financial calculators, get ready with that. If you do not have, you may download an app called BA True Call in your app store. Try and look for this one. Okay, if you are using financial calculator, we call it as BA True Plus Texas Instrument. Okay, so if you do not have right now, you may download from App Store first. We are going to use it now. Okay, now let's have a look into your financial calculator. We are going to use these four main functions for today's class, which are FV, PV, IY, and your number of periods. Now, before you get ready, okay, first of all, if you try using your calculator to press 1 divided by 3, what do you realize? You get 0.33. There are only 2 decimal places. Correct or not? When you use your financial calculator right now. So if I want to have more decimal places, what should I do? I should change the decimal places. So the first activity that we are going to do right now is changing decimal places. We want to have more than 2 decimal places. Okay, so how are we going to do that? First, step 1. Okay, you press what? So step 1. Let me have a look again. So step 1, you press second. Okay, and this button. So this button is what we call as format. So you press second, format. Okay, then step number 2, you key in. Okay, key in the number of decimal places that you want. Okay, let's say I want 6. Maximum is 9. You can put in the number that you want. So it shows DEC. DEC means decimals. Okay, can Okay, good. So next one, we press enter. Okay, then lastly, you press step 4, you press second and CPT. CPT means quit for this one, but CPT means compute later on when we use the function. Okay, so from here, you will be able to try out when you press 1 divided by 3, you should be able to get 0.333333. And so are you able to change the decimal places? Anyone has any problems regarding this? So this is just the first activity, not just in case you want to have more accurate answers, which is more than 2 decimal places, then only you will need to change it. Now remember, when you use financial calculator, every time you do one question, you need to clear your previous work or reset. Why? Because every time you finish one question, all the calculation will be stored in the history. So if you do not clear it up, or if you do not reset, okay, all the past calculations will be stored in your calculation for the next calculation. So that means what? After you did your first question correct, the whole thing will be gone. I repeat, when you do financial calculator, every time you do a new question, you need to clear everything or reset, because it will store the previous memory. It will store the previous calculations. So if you do not reset or if you do not clear everything, it will be stored for your next calculation. So the whole thing will be gone. Okay? All right, good. So we are done with this one. So these are the things that you need to know for your topic 4. Okay, so now let's have a look into your tutorial questions. Okay, so first tutorial questions, I'm going to use this again. Okay, so first tutorial question is about, they're asking the impact of higher interest rate on FV and PV. So if the interest rate here is increasing, so future value will be increasing. Okay, what about for present value? Because R here is my denominator, so when R is increasing, what happened to my present value? It will decrease. Okay, so the first question in your tutorial, you can just get it from the formula itself. Okay, so we see the relationship between this one and this one. Okay, this one, this one. Okay, now give me a while, so let me get this up. Okay, now let's straight away have a look into the calculation questions. Okay, so the first question over here, Okay, the first question over here, we are saying that calculate future value. So you are being given all the information, present value, years, and interest rate, but you do not have future value. So how? So first of all, we can use the formulas. Let's say FV equal to present value bracket 1 plus R power of T. So we just put that in. The present value is 3150 bracket 1 plus interest rate of 18%, power of T. T is 7. Okay, so at the end, you will get these answers, which is you will be able to get this 10,034.24. Okay, so this is the manual methods, but I would like to show you how we are going to do this in your financial calculator. Okay, so let's use financial calculator. First, before you do everything, you must press second clear work, or you can say you can press second reset enter. Second reset enter. You must press either of these first. Usually, I will press second reset enter so that it will really clear up all the previous calculations. Okay. So now next is you key in the value first, followed by the function. Okay. So for example, I want to key in present value. Okay. Present value is 3150. Okay, 3150. Now, present value, you must key in the negative sign. Okay, if not, you'll get the wrong answers. So how do you press negative? You must press this symbol. Okay, present value. Then how much is your interest rate? Is 18. 18 is your IY. Press 18 followed by IY. Okay, now, and then press 7. Okay, press 7 and N. Okay, then what you want to compute? You want to compute FV. Okay, you compute FV. So at the end, let's see what do you get. Okay, so compute FV at the end, you will be able to get the same answers. So in exam, what you need to write? You only need to write whatever you key into your financial calculator. This is your answers that you need to write in your exam only. Only this part that you need to write. Okay. Can anyone, if are everyone able to get the answers or not? Okay, let's do one more example. Using financial calculator, focus on financial calculator. Okay, so now question number 2. Okay, again, you can write it again, second clear work, but I expect you to write one time only, it will be enough. Or second reset enter also can. Okay, so what is the present value? 8453. Present value must key in negative sign. Okay. Then followed by IY. IY is how much? 6. Okay. And then how much the number of periods? 19. Compute FV. So you press compute FV and you will get the final answer straight away. 25,575 and 39. So what you need to write in exam? The things that you need to write in exam is only these parts. Okay, so now you can use a financial calculator to derive the next two. Now let's have a look into the next question. Assume the total cost of a college education will be this amount. Okay, when your child enters the college in 18 years, you presently have 75,000 to invest. What is the annual rate of interest that you must earn on your investment to cover the cost of your children's education? So you must be able to identify the component first. 330,000 is what value? Future value that you must achieve. 18 years is number of periods. Okay. This one, 75,000 is your present value. So what you're calculating? You're counting R. Okay, so you can draw in the timeline. Currently, this is the present value. Okay, you need it you need it within 18 years. Okay, at this future value of this amount. They will not show you the timeline. Okay, so now you need to calculate what is the IY. Okay, so same thing. Second, clear work. Or second, reset enter also can. Okay, you just need to write one time. Okay, then straight away write. Okay, so PV, remember to key negative sign, 75,000. Okay, PV. Okay, then next, 330,000. Is your FV. Okay. Then number of period is 18. Straight away compute IY. You get your answers ready. This is what you need to write in the exam. Compute IY. Then what will you be able to get? 8.39. Okay, so this is what you need to write in exam, like this. Okay, now for those who are using manual methods, this is the manual calculations. Okay, let me do one more question to show you as well. Now, Prudential Incorporated has an unfunded pension liability of 750 million that must be paid in 25 years. To assess the value of the firm stock, financial analysts want to discount back. Discount back to means what? To find present value. Okay? Discount is this liability back to the present. If the relevant discount rate is 7%, what is the present value of the liability? So identify all the values and make sure you know what it refers to first. So this 750 million is going to be paid in 25 years. So what value is this? Future value. Okay, so that is your future value. Okay, and must be paid in 25 years. 25 years is your number of periods. And 7% is your IY. So what you are calculating at? You are calculating the present value. Now, when you write, okay, first of all, you write second, clear work. When you write in exam, it doesn't matter, let's say you want to write the PV or FV first. Like for example, let's say for my case, I prefer to write it this way. I will write FV equals to, I will write like this usually. So FV equals to 750 million. Okay. But when you press calculator, you key in the value first, followed by the function. As long as you know how to key into calculators and get the right answers, then I'm fine. But I prefer to write like this. FV equals to this amount, and then N equals to 25. Okay. IY equals to 7. And then straight away press compute PV. Definitely you will get a negative answers for PV, but we ignore the negative sign and straight away get the answers. Okay, so let me know what's the answers, and at the end, this is what you need to write in exam only. So let me move down a bit. Okay, so you should be able to get these numbers. So you should be able to get the present value of 138, 186, 883. So these will be the answers with the use of financial calculators. Okay, so if you're using a manual approach, this will be the formula. But if you're using financial calculators, we are just going to write those things on the right. Okay, so I pause for a while. Okay, next question. Okay, in 1895, the first US Open Golf Championship was held. The winner prize money was 150 in the previously. In 2009, the winner's check was this amount. Okay, so what was the annual percentage increase in the winner's check over this period? And then if the winner price increased at the same rate, what will be it in 2045? You have two questions here. Do you realize in this question here? So what is the first question they're asking? Okay, first question in this question here is you need to calculate the annual percentage increase, which is to calculate IY. The second question you need to do is to with the assuming at the same interest rate, okay, how much it will grow the future value in 2045. Okay, so we do the part A first. Part 1. Okay, so we press second clear work. Okay, of course you do have to always write, but I'm just showing you. Okay, now first of all, we know 150 is the present value, so 150. Okay, negative present value. Okay, now what the future value is the 1.35 million. Okay, so 1,350,000 is your future value. Okay. Now, how much is my N? So from 1895, so you see from 1895 to 2009, how many years? Now, when you calculate years, you need to calculate the present years as well. But in finance, we put it as year 0. Currently, we put it as year 0. So we don't have to calculate current year as 1 year already. So we can actually use minus. We can just use minus from 2009 minus 1895. Then we should get the answers ready. There's no need for us to add on 1 again. But because when you calculate number of years, you have to calculate the present years. But the present year in finance is called year 0. So therefore, we straight minus 2009 minus 1895 is how much? 114. 114, right? So 114. Okay, 114. So 114 is my N. Okay. Then I need to calculate IY. So compute IY. You will get 8.31. Okay, so these are part 1 questions. Once you have these figures, we can do part 2. Okay, so part 2, assuming that it grows at this interest rate, so we need to find out how much will it be as a future value, okay, in 2045. So therefore, same thing as well. Now my present value is the 1.35 million, the previous future value in the part A. So 1,350,000. And remember to key in the negative sign. Is your present value. Okay, where do I get these figures from? Because these figures was the future value just now. Okay. And then move on. You are being given IY IY is 8.31 from the previous question just now. Okay, and then number of periods, 36. Okay, because from 2009 to 2045 is 36. And now you can compute your FV. Okay, at the end, you should be able to get this amount, which is 33,900,213.39. Okay, so for this one, this is what you need to write in exam. And this is the answers for part 1, answer for part 2. Okay, so let me change this one. It is N, not IY. Sorry, my bad. So you realize that using financial calculators will derive the answers faster, huh? Okay, so now let's move on to the next question. There's quite a number of questions for today's class. Okay, now this one here, calculate the rates of return. Okay, so although appealing to more refined taste, art as a collectible has not always performed so profitably. So during 2003, okay, Sotheby sold this sculpture, okay, at auction for a price of this amount. Okay, unfortunately, for the previous owner, he had purchased it in 1999 at this amount. So you must know which one is present value, which one is future value. So now they're asking you to calculate the annual rate of return, which is FV. Okay, so therefore, we can just calculate very quickly here. Okay, so let's say I can just write another way. PV straight away equals to 1,2,3,7,7,500. Okay, remember to press this plus minus. Okay, and then FV is 10,311,500. Okay, and then N is equals to 4. All right, from 1999 to 2003 is 4 periods. 4, and then what we are calculating, calculating IY. Okay, so you will get negative because it's the value is falling down, so you get negative sign, negative 4.46. Okay, that's the answers. As long as you know when you press into a calculator, you press the value first, followed by the functions, then it's okay. Because it doesn't matter how you put the whether you put the values first or put the function first, it doesn't matter. Okay, so that's the answers. Okay, now next question. Okay, next question here, what is different is you have cash flow. Okay, so investment X offers to pay you this amount per year for 9 years. Whereas investment Y offers to pay you this amount per year for 5 years. Annuity or perpetuity? So investment X and Y, is it annuity or perpetuity? Annuity. Why? Because there is finite series of equal payments. They give you the same payments up to a certain amount of years, not forever. If it's forever, it's called perpetuity. This one is annuity because for a specified period of years. So therefore, we are going to use the formulas for annuity over here, but we are using the financial calculator, so not too worried about the complex formulas. Okay, now which of these cash flow has the highest present value if the discount rate is 6% and if the discount rate is 22%? So two questions here. Okay, so let's do the first one first at 6% interest rate. So at 6% interest rate, how we're going to do here? So very simple, same thing. What's different here is you have cash flow. Now, cash flow we call as PMT. Okay, PMT is your cash flow. What is the meaning of PMT? PMT means coupon payments. Coupon payments means your cash flow. You have your cash flow for this time. Okay, so first of all, we key in 4,400, which is your PMT. Okay, and then we know that 6 is the interest rate. And then we know that 9 is the number of periods. Okay, and what we are calculating at, we are calculating PV. So PV, you will definitely get a negative answers, but we ignore the negative signs, and the end, you will be able to get this amount. Okay, next one, investment Y, same thing as well. You get 6,001 as the PMT. Okay, and the interest rate is 6 as well, which is from the question. And then next one, the number of period is 9. Is it 9? No, 5. Sorry, 5. Pay for 5 years. Okay. And then now we want to calculate present value. Okay, so same thing as well. Okay. So that's for 6% interest rate. So once you are done with the 6% interest rate, you need to do for 22% interest rate. Okay, so that's for part 1. Now part 2. So part 1 is all here. I put it in green color. Okay, and now part 2, I will put it in blue color. Okay, same thing. So now 4,400 PMT. Okay, and how much is my interest rate right now? 22 IY. Okay, and then moving on to the number of period is 9. So if you use financial calculator, you can do it very fast already. Okay, compute PV, and you will get the answers, which is 16,000. Okay, 659.65. Okay, now moving on to the next one, same thing, next investment, 6,100 PMT, coupon payments, and then now my interest rate is 22 IY. Okay, and number of period is 5, which is my N, and now compute PV, okay, which is the answers that you are going to get is 17,468.20. Okay, so you need to find the one with highest present value. So what's the difference here is that just now in part 1, your interest rate is 6. And in part 2, the interest rate is 22. So we want to see which investment will generate highest present value. So when the interest rate is at 6%, it is the investment X that generates higher present value. As when the interest rate is at 22%, it is the investment Y that generates higher present value. So what do we mean by here? Now you see interest rate plays a role in influencing the present value. So what you can see over here is that interest rate is like your cost of weighting, cost of capital, cost of weighting. So therefore, if interest rate is low, that means your cost of weighting is low. So you wouldn't mind the investment to pay you back slowly, because if it takes longer time to pay you back, in fact, you can earn higher returns payments. Correct or not? So therefore, from an investment standpoint, if your cost of capital is high, okay, let's say when your interest rate is high, when your cost of capital is high, then you will expect your initial payback should be high as well. So that means when the interest rate is high, you will expect that every period you will be given a higher coupon payments, higher cash flow. But if your cost of capital is low, like in the first scenario, which is only 6%, okay, you don't mind lower payback. Okay, you don't mind lower payback as long as the payback is for a longer time, because at the end, your total payback will even be higher. So this is why you can see when interest rate is higher at 22%, investment Y will generate a higher present value because it gives us higher payments in every period. So when the cost of waiting is high, then I will expect the money to come to me as fast as it can. But when the interest rate is low, okay, like 6% in the first scenario, we are okay for the investment to pay us back slowly as long as the total payback is higher at the end of the day. So the cost of waiting is low because interest rate is low. So I will not expect a very high payback in every period. It's okay to be low in terms of the payback period as long as it's for a long period so that my total payback will be higher. Okay, so I have provided some reasons here. Like for example, reason is that X has greater total cash flow at the lower interest rate here from this one. At the lower interest rate, the total cash flow is more important since the cost of waiting is not great. But at higher interest rate, Y is more valuable because it has larger annual payments. Because we say that at higher interest rate, getting these payments early are more important since the cost of waiting is greater. Con. Okay, now last one. Again, you have multiple cash flow. Brick and Stick has identified an investment project with the following cash flow. If the discount rate is 8%, what is the future value of this cash flow in year 4? And what is the future value at discount rate of 11% and 24%? Now, here is similar where you are being given multiple cash flow. But do you realize one thing over here? The cash flow are different every year, every period. So can I still use annuity? Cannot. We cannot use it anymore. So we have to use another methods here. So for example, for these questions over here, in year 1, you will get this 910. Okay, so this 910 will be compounded into period number 2, and it will be compounded into period number 3, and it will be compounded into period number 4 for your future value. Okay, because what we are going to calculate for this question is to calculate future value. So I have to take into account all the cash flow because all these cash flows are going to be compounded, okay, until the final years. Now, of course, in exam, they won't show you this timeline. You have to draw it by yourself, okay, but not compulsory. Okay, so therefore, first, what you need to do is, we do like usual, we calculate future value. You put in 910, negative PV, make sure you put negative sign. 8 IY, interest rate is 8%. Number of periods is 3 because it's compounded 3 times. Okay, and then compute FV. Okay, now same thing for next one. For next one, you can see here 1140 is compounded 1 time here and then 1 time here. So compounded 2 times. So if I have to calculate the future value, same thing. I use 1140 PV. Make sure I put a negative sign. 8% IY, 2 as a number of periods, and compute the FV. Okay, and lastly, okay, so we calculate this cash flow compounded 1 time only from year 3 to year 4. Okay, so PV, make sure you put a negative sign. 1360 PV, 8% IY, period compounded 1 time, N is 1, and compute FV. Okay, at the end, you have this you have this 1002 in year 4 as well. This one, and you get it last year, so no need to do any compounding. So you straight put it as 1002. Okay, when you add this up, when you add these 4 values over here, 1 value, 2 value, 3 value, and 4 value, okay, at the end, you get this amount. So this is the answers when you press using calculator. There might be slight differences when you use the manual calculations as compared to this one, but it's okay. Small discrepancy only. Okay, but at the end, as long as you are able to get these final values, then it's correct. Okay, you do the same for 11% and 24% as well. So for this questions, you are using the future value of the formulas only to derive the answers. And the reason why we cannot use annuity approach is because the cash flow are different across all the 4 periods. Okay, so these are the things you need to know for your topic 4, tutorial 4.